The final part of our lesson today is asking about the angle between two planes. And the angle between two planes, I think this is probably best understood visually, and then we can look at it from there. So we have 4x minus 3y minus 7 equals 0. So that one doesn't really have a z. 3y minus 7 equals 0. And then we have 3x minus 2y plus z plus 4 equals 0. Right, so you see you have two planes, and of course they're going to meet. Kind of makes an X pattern if you look sort of straight at them. And the question is, what angle are they crossing one another at? So the angle between the two planes. Now, this is a bit of a challenging idea to try to get directly. However, what we can use here is we can use the idea that the angle between the planes is related to the angle between their normals, okay? Their normal vectors. And so essentially what we're going to say is we're going to define the angle between a pair of planes as equal to that of their normals. Okay, so for example here, normal 1 is going to be 4, negative 3, 0. Normal 2 is going to be 3, negative 2, 1. And if you zoom in and sort of look at these two vectors, okay, and we take the angle between those two vectors, which we can get pretty easily. I'll just have GeoGebra do it, but I'll go out and do it afterward. You see it gives an angle of 15 degrees in between those two vectors. So that 15.82 degrees corresponds to the angle here. It's really hard to see this, but the angle here between the planes you can see is quite acute. I'm not sure if GeoGebra will do this, but oh yeah, it will. Okay, so it'll actually calculate an angle between the planes for you, and you can see that whatever angle their normals meet at, the planes also meet at that angle. Now, just to be totally clear, the normals, we know, could end up pointing the other direction. They could point in a negative direction, right? Which would make the angle between them not 15, but 165 or 164.18. And 180 minus that number. So it's just important to realize that the angle between the planes could be the angle between the normals, or it could be the 180 minus that number. But in either case, it's still the same. We still think of it in the same way, and either answer would be right. So in order to find, we just need to find the angle between the two normals. So let theta equal the angle between the two normal vectors. Then we know that normal 1 normal 2, normal 1 dot normal 2 we know is going to be equal to, we just go back to our sort of angle formula, is equal to magnitude n1 magnitude n2 cos theta. And there, as soon as we have that, then it's actually possible for us to determine the angle between the two normals, and thus the angle between the two planes. So to do that, remember, we're just going to fill it out. 4, negative 3, 0 dot (3, negative 2, 1) is equal to, okay, now we're going to do the magnitude of the first one, which is root 25, or just 5. The magnitude of the second one is going to be 9 plus 4 plus 1 is root 14 cos theta. And there we go. So we just need to do the dot product and we'll get our answer here. So 4 times 3 is 12. This plus 6 is 18. So we can just bring the fraction over here. So we got 18 over 5 root 14 equals cos theta. And therefore we just do the inverse cos of 18 over 5 root 14. So we'll just quickly do that here. 18 divided by 5, a divided by square root 14. And then we do inverse cos of that. We get our 15.82 degrees. So theta 15.82 degrees. And that would be the angle between planes. Okay, and that's that. Just also, let's just make a note, 180 minus 15.82 would also be accepted, because it's just like, it would be looking at sort of this angle, the wide angle between the planes. Either one of those is an acceptable answer, so you can give either. So for today, there's a bunch of homework down here. It's worth a shot looking at. Some extra questions here just to make sure you're really practicing this and understanding it. And your first assignment is also available on this, which is just here, scalar equation of planes. So again, we need to determine the scalar equation of a plane, and give the d value. We need to find the distance between a point and a plane. We need to find the angle between two planes. Again, with this one, I'll look into the coding of this, but I believe either answer is okay. Although actually, wait, no. I'll check that. The y-intercept of a plane, remember, set the other two to 0 and find y. And then this one, you're finding the value of a plane knowing what is parallel to it. So that's going to get you thinking a little bit. Okay, I'll be back tomorrow and we can discuss some questions, but we're moving on tomorrow to talk about intersections of planes and lines. Please post any questions on the website and I'm happy to answer them.